Well, good morning, everybody, and thank you for hosting us here to CAM-BIM. Just a quick question with a show of hands. How many of you have heard of the Site C project? Or maybe, maybe how many have not heard of the Site C project? That would be a better question. So yesterday I had the pleasure to meet Jerry Latman for the first time in person. We've exchanged emails and all that. And one of the first things he pointed out to me is like, you had more hair in your picture. And I said, that's because I've been working on this project for the last 3 years. Now, I did get a haircut yesterday, so that's why it's a little shorter, but it has affected my hairline. So the Site C Clean Energy project, we're just going to talk today a little bit about it, a little bit about the speakers before we get started. So I've got about 17 years of experience in the structural field. I've done the last 6 years as BIM manager in leading multidisciplinary teams. And I've been at the Site C project for the last 3 years or so. And this is Matt Lee.
Show the microphone here. I'm Matt Lee. I've been working on the Site C project for about 5 years now. I manage the user requirements for drawings, so CAD, Revit, and BIM. I'm excited to present here with Rodrigo and on how we tackled this massive undertaking, which is the Site C project. So here's our presentation outline. We're going to talk about the overview of the project, the client mandate, the project execution, and then we're going to get into the challenges and successes we've had over the 3 years on this project. So the project overview, the Site C dam is the third on the Peace River. It's located near Fort St. John. The estimated cost is $10.6 billion. Construction started 2 years ago. The completion is 2024, and the Site C dam will generate enough power to power 450,000 homes in BC per year. So here's an image of the final product after construction. We have the 1 kilometer long earthfill dam on the Peace River. In the back there we have the substation and the transmission lines, and what we'll be talking about today is the generation station and spillway, which is comprised of 4 major components, which is the powerhouse, the intakes, the penstocks, and the spillway. Okay, so we have an elephant. That's a white elephant. I want to talk about any white elephants related to the project as far as what you've heard on the news or people talk about the project. But I do want to make some quick comparisons, some fun facts about the project. And we're going to use this elephant to kind of put it into perspective. What you're looking at here is a slice through one of the turbine and generator units. If we look at just one of the components there, one of the big ones, that's a rotor. And we want to compare it to one of these elephants. Now, a full-grown elephant, it's approximately about 5,500 kilograms. And can anybody guess how many of these elements it would take to match the weight of that rotor? Any wild guesses? 4. Huh? 20. It would take approximately 110 elephants to match the weight of a 600-ton rotor. Okay, so these are big, heavy parts that we're dealing with inside of the project. So it's besides the size, we're also dealing with a lot of complexity and a lot of weight, a lot of things that are challenging in here. And of course, there are 6 of these inside of the powerhouse alone, because we do have 6 units that are going to be built inside of the powerhouse. Now, if you take a look at this image right here, this is a section through what we call the intake, penstocks, and powerhouse structure. So the water passage, where the water from the upper reservoir travels inside of the generating station and it generates electricity and then goes out into the lower reservoir. So you can see here by the arrows, the flow of water comes out of the draft tube, and it helps to spin the turbine. Now, the flow rate of water is about 423 cubic meters per second for each unit. So we're talking about a lot of flow of water. That's enough to fill an Olympic-sized swimming pool in about 5.9 seconds. Okay, so we're talking about a lot of water. Another fun fact is that if we have 423 cubic meters of flow of water going through this water passages, how fast can you spin that rotor, that 600-ton rotor? And the answer to that is 75 RPM.
So 75 revolutions per minute. So it's quite fast. There's a lot of water that travels through this structure. It's a massive structure. We're not dealing with 8 or 10-inch walls. We're dealing with 2 meters, 3 meter thick walls in order to be able to support something like this. Here's another fun fact. We're at the Pinnacle Hotel. If we take the footprint of this hotel, how many of these hotels would it take to cover the footprint of the generating station and spillway? Any guesses? It's 27. So that's only if I measure that correctly from Google Maps. Here's a picture of the Revit model, okay, for the concrete alone. And so far we've modeled about 700,000 cubic meters of concrete, equating to about 4,900 lifts. So that's detailed inside of the model. So there's a lot of work that went into that. And there's several numbers of models that are composed of that. That comes complete with about 40 kilometers of water stops that are modeled inside of all the joints inside of this concrete structure. So it's quite a bit of detail and effort that's been put in to put this model together. So I'm going to hand it over to Matt here.
So our client mandate, we knew 3 years ago, we knew that we wanted to have a 3D model for Site C. We brought Rodrigo over for his expertise and see if we can get our structures, the 4 components I mentioned earlier, into a 3D model and what was the possibilities, what we could do with those 3D models. So the initial conversation we had, as BC Hydro and myself included, with Rodrigo, went a little bit like this. Not exactly, but this is kind of the gist of what we talked about. We knew we wanted a 3D model. So Rodrigo said, what kind of 3D model do you want? We knew we wanted a Revit model. So his response was, what do you want out of the Revit model? What do you want to do? And at this time, we were doing a lot of research. We're looking at the possibilities. So we said, hey, we want all the bells and whistles. And he said, so you want BIM? And we were like, well, what is BIM? And he said, it's all the bells and whistles. So so then we said, okay, let's get started. So that was our mandate. So our mandate started with a 3D model, and it evolved. We knew we had to develop BC Hydro standards so we could bring them back and use them in-house for generation projects. We knew we wanted to have all the construction documentation out of these models, improve collaboration, internal, external, also with our contracts as well. I'm going to go back. I guess again, there we go. We knew we wanted to develop a BIM execution plan. We wanted it enhanced feedback from the user and stakeholders. We knew we wanted to have record models at the end of the day, and we knew we wanted to put this into facilities management, which we're still sorting out at the moment.
Okay, so we're going to talk a little bit about project execution. This is a high-level overview of what the effort that it took to be able to put something like this together with all the complex requirements that this project has, and also the timelines that we have to deliver it. Oops, wrong one. Okay, so for the project execution, we're going to be talking about some of the major contracts that are involved specifically to the generating station and spillway. There is more contracts in this project that I have years of existence, so I can't talk about all of them in 30 minutes, and I don't know about all of them as well, but we'll talk about the generating station and spillway scope. So the GSS, that's what we refer to as generating station and spillway. You'll hear that term a few times through the presentation. So we'll talk about the BIM scope for that. We talk about the team composition, what it took to basically get to the point that we're at right now. We'll talk about the deliverables based on what the client requests from the engineering design team, the project structure, what we did to put it together, and also the contract interfacing, which is a hugely important part of how we're delivering this project to all the stakeholders. So there's 5 major contracts that we'll discuss here, and like I said, there's a whole bunch of other ones, and I'm trying to cover as much information as possible, but I might miss something about it. It's just too much information to put into a slide. The generating station and spillway contract is our deliverable right now. We have turbines and generating contract we have to interface with. We have large cranes contract that we have to interface with. We have also hydromechanical equipment for all the stop logs and the gates and all that operate in the structures. And we have to interface with that as well. And we have what we call the completions contract, which is another one of the really large contracts for the project, and that basically covers most of the mechanical, electrical systems, plus other architectural and structural components that are going to be finalized after the main part of the work. So as far as the BIM scope, the goals for the project, the BIM goals for the projects were to deliver, first of all, high-quality construction documents that were coordinated. I mean, we're talking about a lot of documents here, so they need to be coordinated somehow to reduce errors. When we're dealing with construction, reducing errors is basically a time-saving and a cost-saving factor, right? So we wanted to have improved collaboration. We have an extremely large team working on this project on the design side, but at times it feels like they're working in silos. Everybody's doing their design, worry about their deliverables, and the collaboration aspect of it kind of gets left behind. So we wanted to create an environment where collaboration was not improved, but forced upon people to be able to do their work. Another one of the factors was to improve the team efficiency. We had a lot of work to deliver in a short amount of time, as you will see later on in the slide, and we needed to do it efficiently and make sure that we were delivering on time because of contract restrictions and all that, or consequences of being late. We want to be able to do an accurate 3D model, so the approach that we're taking is that we're modeling as much as we can. So what you see in the drawings, it's basically coming from a 3D model at about 90% of the content that's in there. Okay. We wanted to do real-time cost estimation because there's a lot of changes going in a project like this. We do a design, the design goes through the user requirements, we get input from many parties, and then the design changes. But there's cost implications, and the client needs to understand what it would cost to make changes that are required by everybody. So we wanted to have all the major components that would have a significant impact and have that information real time. The other aspect of the goal is, the other goal that is extremely important, like I mentioned earlier, is the interfacing between all the contracts, because the way that this project is going to be built, the generating station and spillway doesn't include any of the, or very little of the mechanical, electrical components, but we have to design with the provisions to allow for all that to be built inside of what is an extremely busy and complicated building. So we have to make sure that that information gets taken care of, and that it is portrayed in documents that we're going to hand over to the contractor to be able to build the initial phase. The other aspect of a BIM goal is, BC Hydro has a lot of hydroelectric facilities, and therefore they have a lot of users and people who do maintenance in this facility day in and day out. And one of the things that we took as part of a challenge of the design is we need to go into these facilities where they work and figure out what their problems are. At the same time, we wanted to get valuable feedback from the same people that are doing the work day in and day out, so that we could improve the design for them to be able to facilitate their day-to-day activities. So through the use of 3D technologies, we've been able to encourage their participation at looking at the actual facility through 3D models on the screen or virtual reality, so that instead of using 2D drawings where you capture a lot of stuff, but you might miss a few things when it comes to space or logistics. The BIM uses for this project, and again, a lot of this stuff was decided or worked, or it came naturally as the project progressed, because there was no real mandate on a contract to be able to have a scope right from the beginning, from the get-go. So there was a lot of teaching and conversations that went on, and we can do this if you do that, and so we ended up with a lot of different uses of BIM throughout the project. And the first one and most obvious one is design authoring, because that's a tool that we're using to basically design this structure, and it's massive. So it's complicated. So it's really something that that was probably the number one BIM use that would have been mandated if we knew what we're talking about from the beginning. So the next one is a cost estimation. Again, as I mentioned earlier, we want to have real-time cost estimation to the changes as we're progressing the design so that the client and contractors have accurate information of what it would cost to put this project together. Design review as well is another one, and again, involving the users, the people who do the maintenance, the stakeholders, the people designing the building as well. We had people in this project, and we have about 300 of them working on the design of this facility who had never worked in 3D before. So this definitely upped their game and the ability to get information that would help them a lot in the process. We've done different types of analysis, so we use the models to do finite element analysis, structural framing analysis, lighting analysis. So we have been able to use the same source of information where we're doing our authoring of the model and put it into other software to be able to do the design and help in that aspect as well. So there's no we do a model for drawings here and we do another model for analysis here, and they might not match. Everything comes from the same source of information. So the next BIM use is 3D based model coordination, and that's in BIM. That's everybody talks about clash detection and review and all that kind of stuff. And this project isn't any different. We have regular sessions with the entire team to be able to make sure that this project is coordinated accordingly. We've done a lot of phase planning as well. It's a massive project for construction. We've dealt with the different project schedulers and people that are trying to figure out how we're going to build this, to be able to put some kind of a sequence and try to somewhat match the deliverables that the contractors or the preferred proponents might have for their plans for building the project. So basically, we can say that with the preferred proponent that was selected, we are somewhat matching on deliverables. There are some things that need to change, but the planning helped a lot. So we don't have to change a lot of what we're doing as far as what we're delivering and when we're delivering it. The next thing is, and this is a very important one for me, but I'm not sure exactly what it's going to look like because we don't have a signed contract with the preferred proponent yet, so we don't know exactly what it's going to look like as far as the interfacing between the design team and the contractor. But we wanted to build a model that the contractor could actually use. We didn't want the contractor to build their own model to do it for construction. That would be wasting time. So that was one of the big things that we talked about at the beginning and what we pushed forward for. And the last item in the puzzle is the record model. BC Hydro wants an accurate model of what is being built, because one of their complaints is that in their big drawing vault, where they have all of their as-built drawings for everything they have as far as infrastructure, a lot of it doesn't match reality, right? It's not what was built. It's not what's in their drawing. They want something that matches that. So that's another deliverable. As far as the team working on directly on the design and the BIM and everything else, we have 3 offices, 2 here in Vancouver, 1 in Montreal. We got about 40 plus engineers, 9 modelers, and 15 drafters that are doing the job. Okay, and it's a lot of work. For the GSS deliverables, okay, just so you get a big understanding of what we have to do for that phase of the contract, is that we basically have to produce all of the civil structural components that are going to house everything else that goes in that powerhouse. So all the mechanical systems, electrical system, architectural features, anything else that goes in there, but the civil structural component is the first contract that's in there. We have to include in there some of the drainage, piping, and watering systems as an important component in the powerhouse. We have to do the architectural envelope as well on that contract, and we have to have all of the embedded items that are inside of this structure to make sure that they're accounted for, that when the next group that comes in and does design, they have the right information in those models. So that's where the interfacing gets a little tricky. The other part of it is that we're doing performance or prescriptive design of all the MEP systems inside of the powerhouse. So we're basically calling the shots in the layout, but we're not doing detailed design of it. And I'll explain that in a second here. So we have the 4 other major contracts that we're dealing with inside of this project. So it's the turbine and generator. This is a huge one. There's a lot of interfacing to do with that because of the turbine. It needs to make sure that we have all the right spaces and everything to access this structure, and it interacts a lot with what we're doing as far as the GSS is concerned. They're not working in Revit, they're working in different software, and we have to make sure that we can bring that into Revit. So everything that all the other contractors are working on, we need to be able to get in some kind of a format that we can bring into the Revit model for the final master model that we hand over to BC Hydro. That can be a little bit challenging sometimes because we're dealing with very complicated geometry inside of the models. For large cranes, it's exactly the same thing, hydromechanical as well. And the completions contract, which is the next largest contract that we have, and I just mentioned, basically, we did mark and sounding, and we are going to be requesting that Revit models be produced for this part as well. And what this is going to look like as far as the final model, basically what we're going to do is we developed performance prescriptive design models, so we have all those components already in the facility, but not detailed. We're talking about detail level 200, sometimes 300, depending on what we're talking about. Then we're going to hand over these models. So for example, for completions, we're planning to do no drawings. We're handing over models to the contractors that are going to be detailed. It's going to have all the data about who's responsible for what, install, supply, or whatever else, and systems. And then we're going to hand that over to them. They're going to work on detailed design, and we're going to get a model back from them that is the final version of what we have done. At that point, we're going to swap the performance or prescriptive design models with the detailed design models so that we can have the record model for the overall Site C project. Take that one.
So here's an overview of, to date, approximately 2,000 drawings that we're going to issue using the BIM process, Revit. And they're all divided into 9 milestones and their sub-packages as well. So each of our deliverables goes through a 4-stage process. All the packages go through this. So A is the initial internal review by the EDT team, engineering design team, which is KCB and S&C. And then they're submitted to BC Hydro for our engineering review. After that review, if there's any changes or whatnot, we change them, submit them back to BC Hydro for our grading stamp. If we get the thumbs up from Hydro, we issue those through EDT to BC Hydro procurement, which they send out for construction.
So a lot of you have already heard about the term federated model. I don't think I need to explain too well, but in case you haven't, it's basically it's an assembly. It's a single model, and it's an assembly of discipline distinct models that compose one master model that we're working with. In this project, we took the approach is that we're going with the federated model. We want to make sure that no 2 models share the same information. So if you want information pertaining to some other discipline or something, it has to come from them. It cannot be coexist in 2 different models. So that allows for what I call the force coordination, if you will, or force collaboration. For Site C right now, that amounts to 43 models and counting. So these are the first 43 models we've delivered. There is a lot of thought put behind this. We're going to get a lot more models as the project gets delivered, especially when we go through the other contracts. But it's going well. It's not going so bad. So there was a lot of consideration when we sat down to talk about, okay, this is a big project. What do we do to make sure that we can deliver all the different pieces at the right times and make sure that this information gets portrayed in the construction drawings as well as all the different contracts that we have? And these are some of the considerations. I'm not going to name them all, read them all, but basically I'll show you what the importance level is, one being the most important as far as how we would split up and structure all the different models. And I can tell you that it's not as easy as saying we want one model for structural, one model for mechanical. We have, I think, just for the powerhouse alone, 5 different models that are for structures alone, depending on the different contracts and things like that. This one goes for you.
So here's the file types that we've established for the project. Working models, we have dedicated modelers that are inside these. These are all the live models. So no drawings are being produced from these. Once the working models go through a verification process, they are frozen. Those frozen models are linked into the host files, which is the 1020 there. 1020 is our facility code for Site C. So all the frozen models we utilize SharePoint, and those are shared with the entire project. All our contractors have access to that.
If I may add to that, so basically what we're doing is we're not doing any drawing files inside of the model files. These model files sizes are entirely too big, and if we add all these different drawings, it's just humongous. So what we're taking, the approach that we're taking is to be able to do drawings outside of those, outside of the models.
I'll quickly go through the drawings. So like where Rodrigo mentioned, 90% of our geometry is coming directly from the Revit models. All our drawing annotations are housed in the host files, and those are done by our drafting annotation team. And then all the data, we're utilizing Revit for tags and schedules, and any information for the project metadata is directly inputted into the Revit models. The standards, that was a big task right off the bat to develop BC Hydro standards for Revit. We have a lot of standards that we developed for AutoCAD, and we migrated those into the Revit environment. Share parameter files, we just have one. We just watch out who is, in there. We just leave that to Rodrigo and the modeling team. And then the file setup, I've been setting up the files for the team, making sure that the user requirements for the drawings are being met, and basically the drafters can just produce the deliverables for us. So here's a project structure workflow. I'll go through fast. Basically, it's from the EDT and how it gets to BC Hydro. All the design and revisions are fed to the modelers. The modelers are doing the work inside the working models. We go through the verification phase. If that's good, we freeze the model. The models are linked into the host files. The drafters and engineers work on the annotation for those. Then it goes through the draft check. If there's any changes, it just goes through the loop again. If it's all good to go and we're ready for Rev 0, we issue PDFs that are digitally signed, APEG signed and sealed. At the same time, we e-transmit the host files with all the models included. Those are shipped out to BC Hydro procurement, and then eventually there will be a record issue, and then everything will end up, the PDF and the file will end up in our BC Hydro drawing vault.
Okay, so does that sound complicated, or does that sound like a typical workflow? So it's a lot of packages, there's a lot of deliverables that we have, so it's not an easy task to be able to plan this out. We tried to do it in such a way that it was flexible enough that we could produce numerous packages without altering the process as we were going along. Now inside the project, and in just about, I think, every office that I've worked in, and I'm sure a lot of you have, there is challenges, especially when it comes to implementing BIM. BIM is not a new thing anymore. It's been around for who knows how many, 15 years or so, but there's still a lot of people that are not well-versed on it. There's people that reject it. There's people that are not afraid of it. Sorry, not afraid. They are afraid of it, and so they create challenges for us. So as far as people is concerned, one of the biggest challenges was resistance. And this is a large project. We have about 300 people working on here. We have people that were, let's go for it. They're all gung ho about it. And then we have people that didn't want it to do anything to do with it. And that created challenges in its own because they didn't want to change the way that they work. That brings me to the next slide. I've seen this slide on LinkedIn, so I hope I'm not violating any copyrights for these images, but basically, we talked about what BIM can do and how exciting it is to work in this environment. Everybody's like, yes, we got to do it, but then you don't have people who want to change the way that they work. And I think that's one of the biggest challenges that you have when you're trying to implement something that's new and that's different, a little bit different than what you're used to. The next challenge with people that we had is this. So finding skilled resources. Okay, when we started the project, we had basically one skilled modeler for each discipline. That was it. And the rest of the team had to be brought up, trained, and we had to work from basically from zero, which presented a challenge on such a large project. It's not an easy task to deal with something so big and complicated when you don't have the skill set. But, you know, it works out at the end. So this is another one. So basically, that's another image that I hope I'm not violating copyrights on. I saw it online, and it's one of the funniest one I've seen. But basically, is Revit is not AutoCAD, and I get this all the time. It's like, how come we can do this in AutoCAD but not in Revit? And that is, you know, this is a really old problem that we're having when we're trying to deal with BIM, but it's still a live problem in the present project. So it's something that we deal with day in and day out. So we've had our technology limitations as well. So basically, when it comes to the project, we're dealing with a locked server. There is no outside access to it. So cloud platforms and all that kind of stuff, all the goodies, can't use it. So we were basically nailed down to working with a local server, not only a local server, but it was a 9-year-old, well, 7-year-old server at the start of it. It was 9 years old. We just replaced it last year. Okay. So we've had our difficulties on the technology side as well, but you know, we dealt with it. It's just part of the process. The other problem we have is we have multiple companies working on this project, and across the board, the hardware being used is not the same, and that poses a lot of problems when it comes to dealing with models, especially if you're doing collaboration, central models, and all that kind of stuff. So that has been a challenge. We've kind of dealt with it, but we still have some problems with it. And the next problem, and this is a big one, is this is a very long-term project. We need to keep those files up to date, and we all know the issues with updating Revit files. Now try updating 43 Revit files and trying to track what went missing or what went wrong. Okay, so we did several tests. We spent a couple of weekends doing tests on the upgrading to see what would be the effect of the upgrading the files, and we didn't find a lot, except we missed one major thing. And this one was quite annoying because we're producing mechanical and electrical drawings. We decided to go, for example, for structures to go with shading instead of a concrete hatch because it was easier to see rebar and all that. When we turned the models into mechanical and electrical disciplines for their views, we were still able to print shaded the drawing, so we could actually make it look the same as the concrete models, but half-toned. When we upgraded to the next version, that disappeared. So now we have drawings that look different. So you can see what kind of a problem that posed, because we had a lot of people saying, what happened to these drawings? And we tried to get support from Autodesk, and they're developing software. They're working on a whole bunch of other initiatives inside of the BIM world, and this became a low priority issue for them, so we didn't get that solved. And we have to upgrade the models again at some point after we issue all of the constructions, just to keep the models current to be able to work. Because it doesn't end at the GSS. I think the completions contract is still 2 years down the road before it gets issued, never mind when the models get worked on. So some of the other challenges that we have, and this is more to do with modeling, we're dealing with some pretty complex geometry. At sometimes Revit did not handle this geometry inside of it as well as we wanted to. And I could explain to all of you what this geometry is. I'm not going to get too deep into it, but it's complex, and it's not easy to create inside of a Revit. So we had to use alternative software to be able to create the complex geometry and bring it into Revit to be able to use it and make this happen. But it works. So far, we're doing good. You can see a lot of the stuff that's in the models here is what we have so far. So this is a snapshot. Now, we didn't model rebar because it's a massive project. As you can see, 700,000 cubic meters of concrete. That's a lot of rebar. We didn't have enough resources to be able to have full-time rebar modelers and somebody who can handle all that. But we did take the most complicated part of the project where the rebar is extremely important and model the 3D rebar around it. Okay, and that's around the draft tubes. Okay, and that's because we needed to make sure that the rebar, that we had enough concrete coverage in these massive rebar bars that are around this draft tube. So it's, we had to pick and choose what we tackle inside of the project according to the skills and resources that we had. Successes. Okay. So the people successes. First of all, we managed to achieve the BC Hydro Revit standards. Now, how many of you guys have done work for BC Hydro before? How many know of their CAD standards? How many like them? Sorry. So they're very complicated, very convoluted. You just cannot do a straight transfer from Revit to, I mean, you can't do a straight transfer from Revit to AutoCAD to begin with, but that, trying to match what they do is a little bit complicated. So we managed to implement that, and it's being used across the entire project, which is a lot of, it was a lot of work. We worked on this quite a bit. The overall team adoption, before we have people that didn't even want to look at a model, now we have people that can't live without a model. They can't do design without it, or they can't, you know, make decisions without it, so that's a great thing. And we're very happy about that aspect of it. The other success is the amount of input and how happy the users are in that they got to participate in it at a different level in how this facility is going to look for them and what it's going to have inside of it so that they can do their work. We've used tools like Navisworks and other 3D reviewing software, as well as virtual reality, so that they can actually see the facility and walk inside of it before we build it. Forced collaboration. I'm going to change that word. It's not improve. It's forced collaboration and coordination. That has been another big one. We're managing to break through these silos of people working individually in whatever they have to deliver without worrying about what's happening on the other end. If somebody wants to make a change inside of a model, it has to affect everybody, and that change doesn't just happen in their end. It happens. I mean, it's coordinated, and we have processes for that help us control this. So that's been a success. In 3 years and 43 models, we've only had 2 crashes. So we've done a lot of legwork to make sure that we're keeping maintenance. Now, I can't say that the 2 crashes were at good times. One of them happened right the day before we had to issue 300 drawings. Okay, so if it happens at a good time, anyways. But 43 models later, 2 crashes, 3 years. That's not a bad thing. We've done a good job on trying to keep these things up and running for a large team. And a lot of it had to do with again, software compatibility. Sometimes there are users who had upgraded Revit versions or builds at different times, different offices, and that caused models to crash and a whole bunch of other issues. And the other success is that last week we've submitted our biggest milestone, and that was milestone number 2 of 9 for the GSS, and that was 600 drawings that we issued last Thursday. So that was the last 3 months have been extremely busy and convoluted with working a lot of overtime and a lot of trying to achieve this milestone.
I'll add to that.
Yeah.
So with the BC Hydro standards, after we complete the project, the goal is to bring all these standards back to in-house at Hydro Generation and set up our own BIM projects moving forward. And then one that's not listed on here that I've added to my presentations internally over the last 6 months is safety. I presented on how we're doing the drawings and models and things like that. As soon as I mentioned safety, because safety is number 1 for BC Hydro, I get a lot of positive feedback for that, because the one example I have is if we have even a VR and we have a new employee or a contractor coming to our site, we can show them our facility in VR, show them where they're going to park, where they're going to check in, where they're going to do their tailboard, where they're going to be working, and if that can prevent an injury or a fatality, that's huge. That's a huge benefit of BIM. So I'm really getting positive feedback internally from BC Hydro for pushing BIM as a safety tool and possibly integrating that in all our safety meetings, tailboards that we do. So I think that's a huge benefit of BIM.
Yeah, so basically those are a lot of the successes. The other success is to do more with software integration. So we've used a variety of different softwares that are listed here. The one I'm missing is Advanced Steel. We've also used that to do all of our structural steel stairs. There's a lot of them, and ladders and platforms. So we've used a large array of software that would help us
put this thing together inside of a Revit environment, but, you know, taking care of the needs of different people that wanted to have a high level detail of this model. And of course, last but not least, we did use AutoCAD as well. So, you know, thumbs up to AutoCAD, it's still alive, and we still use it. With that, we wanted to present to you a video of what we've done so far, so you can get a scope of what this facility will look like once it's built. And we'll see if it plays. It's a short video. Yeah, it's playing. So I have not been ignoring this red light. I completely missed it. So I went over by quite a few minutes. So thank you guys for the time, and thank you to BIM for hosting us. And if there's time for questions.
Yeah, thanks Matthew and Rodrigo. Very impressive project and very impressive presentation. Obviously a lot of work and a lot of management around that. Not only the team, but the models. That's very impressive. We probably have time for one quick question from the audience, if anybody has a question.
Right. My name's Jorge. I work for Omicron. I just was wondering if you could talk a little bit more about, you spoke about getting the contractor to use the actual BIM model.
Yep.
From just a legal standpoint, is that something that's built into the contract, or what's the user interface that they're going to be using? Like, how does that work?
So there's no contract signed yet. I don't know what the full language of it is. I don't know what the capabilities of the contractors are right now. And I don't know that the contract will be issued based on BIM capabilities. To tell you the truth, it's more about who can build a dam this size. Basically, what I'm saying as the BIM manager of the project is that the models that we are submitting to the contractors are exactly the same things that are on the drawings. The drawings are composed of the model. So if they want to be able to
get something that is what's on the drawings, that are the contractual documents that they're going to receive that are part of the contract, they should use the models that we have. That's the extent of the, I don't know if that answers your question or not.
Yeah, no, that's, yeah, thank you.
Yeah.
Right on. Good. Well, thank you very much, Rodrigo and Matthew.